ازيكم يا شباب عاملين ايه؟ ان شاء الله تكونوا كويسين. Lesson 2 Algebra Adding and Subtracting Matrices. If A and B are two matrices of the same order, you can easily do the addition operation and subtraction. Look here. If you have A equals 2, 1 in the first row and 3 and negative 2 in the second row, and B equals also 5, 2 in the first row and 2 and 3 in the second row, so you can easily add or subtract whatever. Why? The same order and the same number of rows and column. So A plus B equals 2 plus 1, which they are located in the same place, equals 7. 1 plus 2 equals 3. 3 and 2 equals 5. Negative 2 and 3 is equals 1. Let's take the first example. If A 1, negative 2, 3 and 5 and 4 and 2, and B negative 1, negative 2, 5 and 1, 3 and 2, and C 2, 0, negative 1, 3, 4, 6, find each of the following. Number 1, 2A plus C transpose. To get C transpose, you have to transpose all elements in C. Change the row to column and this row to column, so it will be 2, 0, negative 1, and 3, 4, 6 in 2 column. Now it becomes the same order of A. And here you have 2A, so you will multiply 2 by each element in A. So it will be 2 multiplying each element, 2 multiplying 1 and 3 and 4, and negative 2 and 5 and 2. It will be 2, negative 4, 6, 10, 8, 4, plus C transpose. You can transpose 2, 0, negative 1 as like this, 3, 4, 6 as like this. Add each element. 2 and 2 equals 4. 6 plus 0 equals 6. 8 plus negative 1, which is 8, subtract 1, which is 7. Negative 4 plus 3 equals negative 1. 10 plus 4 equals 14. And finally 4 plus 6 equals 10. Number 2, P plus C. Can you get P plus C? No, you can't. Why? Because P contains 3 rows and 2 columns, and C contains 2 rows and 3 columns. Different order. So you can't add. Example 2. If A equals 2, 3, negative 1, 5, 6, and 7, and B equals 0, 4, 2, negative 3, 4, and 8, you notice that A and B having the same order, 3 columns multiplying by 2 rows. Check that. A plus B all transpose equals A transpose plus B transpose. Now, you are going to get the left hand side and see the answer. And you are going to solve the right hand side and see the answer. And if they are equal, so you check that. A plus B, add each element in A by its corresponding elements in B. It will be 2, 7, 1, 2, 10, and negative 1. And you can get the transpose of this sum. It will be 2, 1, 10 in row, and 7, 2, negative 1, which is in the second column, will be in the second row, as it is 7, 2, negative 1. Now we are going to solve the right hand side. A transpose equals A, its elements. And now if you transpose A, 2, negative 1, 6 in the first column will be the first row, and 3, 5, 7 will be the second row after being the second column. P transpose 0, 2, 4, 4, negative 3, 8, 0, 2, 4 in the first column would be in the first row, and 4, negative 3 and negative 8, which in the second column will be the second row. Now, the next step, we will add A transpose and P transpose. 2 plus 0, 2, negative 1 plus 2, 1, 6 plus 4, 10, 3 plus 4, 7, 5 plus negative 3, 2, and 7 plus negative 8, negative 1. We notice that they have the same result, so we check that. Example 3. Find the values of A, B, C that satisfy the equation. Satisfy the equation means the left hand side will be equal to right hand side. Right hand side you have two operations, multiplying 2 by each element here and add it to this matrix. Left hand side has only one operation, you will multiply 3 by each element. So left hand side will be 3a, 3c, 3b, 9. 3 multiplying 3 will be 9 equals 2 multiplying 8 to a, negative 2, 12 and 6 plus these elements. Now you can add y because they have the same order. 2a plus 4, 12 plus p plus 4 which is p plus 16, negative 2 plus c plus 3 which is c plus 1, 6 plus 3 equals 9. Now you have the equality between the left hand side and the right hand side, so 3a will equals to 2a plus 4. You can get a equals 4 over 5. 3b equals p plus 16, so you will have 3p equals p plus 16. Move p to the left hand side by negative sign, so you will get 2p. 2p equals 16 which is 8. So a equals 4. Why 4? Because when you move 2a to the left hand side by negative sign, it will be 3a subtract 2a which is a equal 4 and b equal 8 as we discussed. Now you have c plus 1 equals 3c. So move c to the right hand side by negative sign, you will get 2c equal 1, and dividing both sides by 2 you will get c equals half. Properties of adding. Number 1, closure property. A plus B is a matrix of the same order. لازم يبقوا نفس الأوردر. Commutative property. A plus B equal B plus A. Whatever الماتريكس اللي start بيها هتبقى same result. Like this. When you add this matrix to this, you get negative 3 plus 4 which is 1. Negative 2 plus negative 1 which is negative 3. And 1 plus 2 which is 3. Negative 3 plus 5 which is 2. Associative property. You can start adding 3 terms by a plus b as a time or b plus c. The result will be the same. If a equals negative 2 and 3 and 4 5 negative 6, b negative 2 1 4 and 7 8 negative 9, c equals 1 3 negative 5 and 6 7 16, then add a plus b, you will get negative 1 negative 1 7 11 13 negative 15. And now add c, you will get the result 0 2 2 and 17 20 and 1. I started adding a plus b. Now start adding b plus c, then add them to a. You will find they have the same result 0 2 2 17 20 and 1. The existence of the additive identity, or you can name it additive neutral. Additive identity or additive neutral from middle to. If you add 0 to a, it also equals 0 plus a or a plus 0 which is a. When you add 0 you will get the same result. Number 5, the existence of the additive inverse. The additive inverse of a is negative a, so if you add a to its additive inverse the result will be 0. For example, additive inverse of this matrix is having the negative sign. When you add them you will get a set of matrix of order 2 by 3 and all have 0. Subtracting matrices. You have to subtract any matrix, they must have the same order. If you have like here a equal 5 2 3 negative 4 and p equals 4 3 5 and 0, when you subtract them 5 minus 4 is equals to 1 and 2 minus 3 is equals to negative 1. 3 minus 5 is equals to negative 2, and negative 4 minus 0 equals negative 4. As we discussed, to carry out the subtraction operation, subtract the corresponding element. يعني هنا 4 first row second column, so I will subtract it from the first row second column, which is negative 2. Let's move to example 4. If A2 1, negative 1 3, 0 4, and B 2 negative 2, negative 1 5 3, and negative 3, and C 0 4, negative 2, negative 6, 8, and negative 2, find the value of 4A minus 2B plus half C. Half C is operation, and 2B is operation, and 4A is operation, and the subtraction here is also operation, and addition is also operation. So you will do 5 steps. For multiplying A, 4 multiplying each element in A, minus 2 multiplying each element in B, plus half multiplying each element in C. You get this matrix as you see. Now you will add, you replace negative here by positive and insert it to each element in P by multiplying. You get negative 4, 4, 2, negative 10, negative 6, and 10, and 6 also. And add them to 0, 2, negative 1, negative 3, 4, negative 1. You can get the result easily: 4, 10, negative 3, negative 1, negative 2, and 21. Important note and remark. Subtracting matrices operation is not commutative and not associative because the result will change. Example 5. If A equals negative 1, 1, 4, 2, 5, 0, 3, 7, 2, and B 1, 2, 3, negative 2, 4, 0, 0, negative 1, negative 3, find the matrix X such that 3X plus 2B equals 1. X here is not only an unknown variable but also a matrix. So you will change 2b to the right hand side by negative sign. You will have A as a matrix minus 2b as also another matrix, and multiply them to third. Why third? To get rid of 3, which is multiplying by x. So you will get x equals third A minus 2b. Let the third outside a biggest bracket, and A is here minus 2, which is multiplied to P matrix. X will be equal third, and when you do this operation by multiplying 2 by each element in P and subtract it from this matrix, which is A, you get negative 3, negative 3, negative 2, 6, negative 3, 0, 3, 9, 8. And now I will multiply third by all elements lying in this matrix. You will finally get negative 1, negative 1, negative 2 over 3, 2, negative 1, 0, and 1, 3, and 8 over 3. Example 6. If A equals 2, 3, negative 2, negative 1, 4, 5, and P equals 0, negative 1, 3, 5, 2, negative 4, find the matrix X that satisfies 2. Multiplying X transpose minus A equals 3B. Now you will move 2 by divided. You can get at the right hand side 3 over 2 multiplying B. Now you will change negative A to the right hand side by opposite sign, which is positive A. And finally you can get the transpose to get the matrix X. Now you can also solve by add and distribute 2 at these elements. You will multiply 2 by xt, x transpose, and you will multiply 2 by negative A. You will get 2x transpose minus 2a equals 3b. Add 2a to all sides, you get 2xt equals 3b plus 2a. And now 2x transpose equals 3b plus 2a. You can multiply 3 to the matrix P and adding the result of multiplying 2 to the matrix A, which is 4, 3, 5, 13, 14, negative 2. Now you want to get x transpose, but first you have 2 multiplying by x transpose, so I will moving 2 to the other hand side by divided. It will be this matrix divided by 2, or half multiplying it. You will get the result 2, 3 over 2, 5 over 2, 13 over 2, 7, and negative 1. To get its transpose, you will change this column to be a row and this column to be another row. So it will be 2, 3 over 2, 5 over 2, and this row will be the column 13 over 2, 7, and negative 1. ان شاء الله يا شباب في اخر اليونت هنقول لكم ازاي تعملوها على الكالكوليتر. اتمنى تكونوا استفدتوا. اللي يقف معاه اي حاجه يقدر يبعت على جروب الواتساب. السلام عليكم.